Hey guys, it's Mr. Riz, and we're going to do section 2.6, which is algebraic proofs. So we're going to start two-column proofs, and these are the easier of the two-column proofs. Most of the stuff you guys should already know how to do from Algebra 1, but we're going to get used to answering in the form of a proof. And what we're going to do first is just review some properties or postulates. Alright, so first ones, we got reflexive property, and what that basically says is A equals A. Now we're going to give two examples here. In an algebra example, that'd be like x over 2 equals 1/2 x. They're the exact same thing. All we did was really kind of change the way it looks. For a geometry example, sometimes we have to, in a proof, say that one side is congruent to itself. So AB is congruent to AB. Symmetric property says if A equals B, then B equals A. So an algebra example, if we have 3x plus 10 equals y, we could change that to y equals 3x plus 10. So if we ever need to switch sides. Geometry, that could be the same thing. So if we got angle 1 plus angle 2 equals angle 3, we can say angle 3 equals angle 1 plus angle 2. Transitive property needs three things: an if, and then. So if A equals B and B equals C, then A equals C. We don't use transitive too often because what we could do is just use substitution twice, was the next one. So we're not even going to go over an example because it's not too often that we use it. In fact, I'd rather have you learn the next one just a little bit more, which is substitution. And substitution just basically says if A equals B. So if we have two things that are equal, then A can be replaced by anywhere in the problem. And I am learning that it's probably easier to type these out than to handwrite them. Alright, substitution as an algebra sense, it is just basically any time you simplify. Alright, so if you have like x equals 3 plus 7, substitution would just basically say x equals 10. You simplified the equation. In geometry though, if we got like angle 1 equals angle 2, and we know that angle 2 plus 50 equals 180, we can substitute that in as angle 1 plus 50 equals 180. So we can use substitution like that. Alright, the next ones are addition and subtraction. They're pretty easy. They're actually called the addition property of equality and subtraction property of equality, but it basically means this. If I have two things that are equal, I can add the same thing to both sides and it's still going to be equal. So A plus X equals B plus X. Also works for subtraction. A minus X equals B minus X. So an algebra example, one that we'll use, if I got like x plus 5 equals 13, if I want to get rid of that 5, I can do x plus 5 minus 5. I can subtract both from both sides. So x plus 5 minus 5 equals 13 minus 5. In geometry, sometimes we could have two sides that are equal measure or congruent. So AB equals XY. What I can do is sometimes add another side, so I can do AB plus CD equals XY plus CD. Running out of room here. Sometimes we have to do that. That's addition property. Multiplication and division property aren't too much different. If I do A times X equals B times X, I'm allowed to multiply by the same thing on both sides. I can also divide by the same things on both sides, and it still remains equal, as long as you're not dividing by 0 or timesing by 0. So a little thing you gotta be careful of. So algebra example that we'll use, if I have, let's do 4x equals 80, I can do 4x divided by 4 equals 80 divided by 4. They still remain equal. In geometry, sometimes we have to double angles. So like if angle 1 equals angle 3, then 2 times angle 1 equals 2 times angle 3. Now the distributive property, what basically you guys know is that if we have A times B plus C, then we get A times B plus A times C. So in algebra, we got 3x, or 3 times x plus 1, or let's do 10, so it's equals 15. I can distribute and you get 3x plus 30 equals 15. Geometry, we could have like, this is a median formula, like if we're trying to find the top of a rhombus or trapezoid, and we know the median length, we can get, okay, 1/2 x plus 10 equals 150. You can distribute in geometry as well. I guess that should be xy, since it's a side. Okay. Well, now these properties, what we're going to do is have a proof, and we're going to make a note here. First thing in a proof, we always state the given. So we're going to make a 2-column proof. On the left side, we're going to put statements. On the right side, we're going to put reasons. Alright, so the very first thing we do, we're given that 2x minus 3 equals 4x plus 7. We want to prove that x equals 5. The very first thing we do is we state the given. So 2x minus 3 equals 4x plus 7. And the first reason is always given. The first reason will always be given. Okay, next. What we need to do is solve this problem. Now, if I were going to solve this problem, I would get rid of this 2x. And to get rid of it, you subtract it. Well, you need to show in a proof that you're going to subtract. So I'm going to take our 2x minus 3, and I'm going to subtract 2x. And when I do to one side, I need to do to the other side. So I should have a 4x plus 7 minus 2x. So I'm showing that I'm subtracting, so I'm going to use subtraction. Now we're just abbreviating here. It's technically the subtraction property of equality, but we're just abbreviating. Now if we look at this, I can simplify this and I can simplify that side, so I'm going to do that. And so the left side becomes negative 3x, or just negative 3, equals 2x plus 7. And anytime you simplify, that's substitution. I just like to put subs. Okay, step 4, we need to subtract 7. So we need to show that we're going to subtract 7. So subtracting 7 from both sides, showing that is also subtraction. And just like before, following subtraction is the substitution, so we're going to simplify. Negative 10 equals 2x. Alright, step 6, I need to divide, so I need to show that I'm going to divide by 2. So division. Hopefully I get some room here. Alright, next I get negative 5 equals x. That's substitution because I simplified. Now, here's the one thing. We get negative 5 equals x. We want to prove that x equals, I guess my mistake. Should have put that there, equals a negative 5. Started the problem off wrong. Alright, but we have negative 5 equals x. We need to make sure that if we want to prove that x equals 5, we need to start out. So what we need to do at the very end, last step, is switch it around. X equals negative 5. And the reason for that, if we ever switch sides, symmetric. Symmetric property says we're allowed to switch sides. Alright, so there's the proof. We're going to spend some time on these because we're going to make sure we understand the algebra proofs before we move on to ones involving geometry. Alright, that is it. Good luck on this section.